from Marcus's Academy. Thank you for joining me in this video. Today I am to teach us how we can actually find the binomial expansion, using a Pascal's triangle. In our former videos, I showed that we can actually use binomial formula to find the binomial expansion. So actually, in my last video, I treated how we can be able to establish Pascal's triangle, right? Which is a representation of what? A triangular array of what? Numbers, which are infinite. Now, and it said that each row of the Pascal's triangle actually represents the coefficient of a binomial. All right, now depending on the degree of the binomial. So now we are still under what? Binomial. Or binomial expansion or binomial series. So I am to show us how we can actually use another formula called Pascal's or pyramid triangular formula, to find the binomial expansion using the coefficients of the Pascal's triangle or the elements. Now actually, suppose we have this the triangular formula to be for instance now, so let's say we are given this problem to solve. We have 2x plus 1, for instance, raised to power 3. All right, so this is a binomial expression of the third degree. It is binomial in the sense that the number of terms there are just 2. Then the index is a positive integer. Because we said that actually n must be positive, right? So at this point 3 is positive. So let us try to find the binomial expansion of this question or problem given to us. Now without the use of binomial formula, I want to apply the pyramid formula. So first of all, you can establish the formula, so be 1 1 1 2 1 1 3 3 1 1. All right, 1 4 6 4 1. Let me stop here. Mind you, this is R4, R3, R2, R1, and R0. So at this point, I can actually continue with the expansion, of the numbers, but I have to stop, based on the fact that the index of the binomial given to me is 3, so our n is known, so I shall find my binomial coefficients, at my row 3. So I shall use all these entries of row 3 to put in a standard form for me to have the binomial expansion. Actually, I can do that offhand, without the establishment of this formula. But now let me do this, So I shall put it in a standard form now, taking 1, that is from this row 3 that I've take good. I take 1, all right, multiplying it by 1 multiplied by the first term of the binomial is 2x, taking the highest power, which is 3, then 1, we take the 0th power, then plus, I take the second, that is this one, 3, multiplying by the first term of the binomial, 2x, subtracting 1 from the power of 3, I have 2, multiplying by 1, and adding 0 to 1, I have 1. So 1 raised to power 1 is still 1, right? Then plus, I take the third digit, which is 3 times the first term, 2x, and the 2 minus 1 is 1, then times 1 raised to power 2, because when you sum 1, 1 plus 1 is now 2, right? So the power of the second term, will be increasing, starting from 0, while the power of the first term will be decreasing, starting from the power of the whole binomial, Then, plus last term, I have 1 times the first term of the binomial, then 1 minus 1 is 0, then times 1 raised to the power 3, that is 2 plus 1 is 3, so I stop, all right? So now, we know that 1 raised to the power 0 is 1. Okay, that is law of what? Indices. Okay. Then this first term here, 1 raised to the power 0 is 1. 2x all raised to the power 3 gives me what? 8x cubed, right? Like in initial law, 2 is cubed, x is also what? Cubed. Plus 1 raised to the power 1 is still 1. Okay, nothing changes here. So 2x all raised to the power 2 will give me 4x squared, right? 4 times 3 is what? 12x raised to the power what? 2. Okay. So again, I have plus 1 raised to the power 2 is still 1. 1 multiplied, nothing changes. So 2x raised to the power 1 is still 2x. Okay, so 3 times I will have 6x. All right. Then plus 1, because 2x all raised to the power 0 is 1. 1 times 1 is 1. 1 raised to the power 3 is 1. Okay, so 1 times 1 times 1 is still what? 1. So this is the binomial what? Expansion. All right, of this problem given for us to what? Expand. So this is actually how you can use what? Pascal's triangle to find the binomial what? Expansion. Now there is observation. Mind you, actually the power of, okay, the number of terms, okay, number of terms involved in the or after the expansion, okay, will be 1 higher than what? The power of the binomial. Okay, mind you, here I have 4 terms, right? After the expansion, the power of the binomial, okay, of the given question is what? 3. Okay, so I say that the number of terms, okay, of the expanded binomial, okay, actually will be 1 higher than what? The power of the binomial. Okay, so again, the sum of the indices, okay, of the product what terms, okay, will give me what? The original the power, the index of the binomial. Okay, so for instance, what I mean is that here in this first term here I have what? 3, right? 3 plus 0, okay, is what? 3. Do you see it? Again, from this second term I have 2 and 1. 2 plus 1 gives me what? 3. Again, from this third term I have 1 and 2. 1 plus 2 is also what? 3. Okay, from this last term I have 0 and 3. 0 plus 3 is also what? 3. Okay, so do you see that actually when you sum the indices, okay, of the terms in the product form, okay, you also have the power of the original binomial. All right. So okay, there are other little observations, okay, but so let us clean, okay. Let us clean to give us another example. Or for instance, you can say, for instance, you may have this to be 2x plus 1 raised to the power 0, okay, from the 0th row, okay. The coefficient here is what? 1, all right. Here, 2x plus 1 raised to the power what? 1. The coefficient here is what? 1, 1, right? Then from the second row, I have 2x plus 1 raised to the power what? 2, okay. The coefficient here there is 1 to 1, right? Again, from row 3, I have 2x plus 1 or raised to the power what? 3. That is the one we just did right now, okay? In row 4, I have 2x plus 1 raised to the power what? 4, okay? So at this point, the power of the binomial is 4, okay? So the coefficients here are what? 1, 4, 6, 4, 1, okay? So do you see that I have 5 elements here? 1, 4, okay, that is 1, 2, 3, 4, 5, okay? So do you see that it is 1 higher than what? The index of the binomial, okay? The index here is 4, okay? And the number of terms, okay, given by this coefficient of the binomial, okay, is what? 5, okay? So do you see it is 1 higher than the power of the binomial? So in that way, okay, suppose we have our fifth row, okay, that will make us to have 1, 6, 10, 10, 6, and sorry, I will have 1, 5, 10, 10, 5, then 1, okay. So I'll have the other one, for instance, 2x plus 1 raised to the power what? 5, okay. So look at what I mean so that you don't get confused. I'm not going to do another question, okay. We stop here. All right, but look at it. Suppose I have 1, 5, 10, 10, 5, 1. Okay, that is my fifth row now. Okay, so it shows that the power of the binomial here is what? 5. Okay, and in that way, as long so far the triangle the numbers expand. Okay, or in a triangular form, the power of the binomial also what increases. Okay, so suppose you don't want to employ the normal multiplication method, okay, or finding the binomial coefficient or binomial expansion. You can use the binomial formula, or you can use what the Pascal's triangle, okay, especially when the power of the binomial, okay, increases. All right. There is still another method we can use to treat this, okay, which is what? Combination. All right, we can use combinatories to see find the binomial what coefficient or binomial expansion of a problem. Okay, so I think this is very clear. Okay, no need to do another instance. Okay, the instances are given here. You can do it when the power of the binomial is 0, when it is 1, when it is 2, when it is 3, when it is 4, when it is 5. Okay, so with the one I solved here is when it is what? 3. Okay, so you can do that on your own using these entries. All right, suppose when it is 5. All right, then use this to find the binomial what? Expansion. All right. Hope you found this helpful. Please do subscribe to my channel. Thank you for